We are starting a new series of Phoenix FD for small-scale liquid simulations using 3ds Max. In this video, we are going to learn basics of liquid simulation, grid, resolution, units, and steps per frame in Phoenix FD. So let's get started. Whenever you are working with Phoenix FD liquid simulation or Phoenix FD fire simulation, you need to make sure that in what units you are working. So let's say right now I'm working is 1 unit. So basically this grid, 1 unit is equal to 1 millimeter. But to work with large scale scenes like waterfall, then big wave or a ocean simulation, you need to change the resolution and you need to make sure that you are working with the units of maybe kilometers or meters. Okay. So if you are working on a small scale simulation, you can work in centimeters or millimeters. But if you are working in big scale simulations, either Phoenix FD for fire simulation or Phoenix FD for water simulation, then you need to work with meters or kilometers depending on the scene that you are having. Now to determine what is your unit setup, you need to go to customize. Then you need to go to unit setup. Now generally the beginners mistake that they do, that they think here it is centimeters, so they just press OK, but this is just a display unit. So what is display unit? So here you can see this is written in centimeters. So if I change it to millimeters, okay, and if I press OK here, you can see it's written in millimeters, but right now it's not 1 unit is equal to 1 millimeter or 1 unit is equal to 1 centimeter until and unless you change it into system unit setup. Okay, so let's just do centimeters here. So this is your display units, the unit that you see in the display here. To change the unit scale, you need to go to system unit setup. Then you need to make sure 1 unit is equal to 1 millimeter or 1 centimeter or 1 meter or kilometer, depending on the scene that you are working with. Okay, we are starting with small scale simulation. So we are going to go for 1 unit is equal to 1 centimeter here. And now we are going to press OK and OK here. In order to work with Phoenix FD liquid scale simulation, you need two things here. One is your grid in which your simulations are going to happen, and one is your emitter. Now let me show you with the help of example here. Now to emit liquid, you need to have a grid as I told you. So let's just have this grid here. So let's just drag and drop it here, something like this. Okay. Now, as you guys can see, we are getting this lines here. Now, this is what we call a voxel. So I am going to explain you in a bit what is voxel also. But now you can see if I play it from here, you can see nothing is happening because we are not having any liquid. Yeah, but it is simulating because our grid is getting green here. Okay. So now to add a emitter, we are going to go to here. We are going to go to standard primitives and we are going to add a sphere, let's say. Okay, and let's just move it upwards. Now to emit liquid from sphere or any object, you need to make sure that your object is in the grid. Otherwise, it is not going to work. So if I am going to do something like this and if I am emitting liquid from this, it is not going to emit because your emitter is out of the grid here. So you need to make sure that your emitter is in the grid here. Now, again, if I click on play here, you are going to see nothing is going to happen because we need to tell Phoenix and 3ds Max that this is my emitter here. Now, how you can do that? With by clicking on this create a Phoenix liquid source and just drag and drop it here. Just press W key and now go to your settings here. And now here you can see we are having this emitter node. So just click on add and then click on this sphere now. Okay, we are going to go by default value right now. And if I click on play, now you can see we are getting this emitter here and we are emitting liquid from that emitter. Okay, it's getting killed here. So if I play here again, now if you play from here, it is going to simulate. And if you are going to play from here, it is going to play the timeline here. So right now, if I click on this time configuration, you can see I'm working with NTSC, so it's 30 FPS. I'm going to go for film, which is 24 FPS, and I'm going to increase my end time to 200. And I'm going to make sure that I am working with real time here. And now if I'm going to play here, you can see we are emitting this liquid here and it is getting killed. It is not basically sticking in the grid here. And if you see now we are not seeing any emitter because if you remember we simulated till 100 frames only here. Okay, so that's why we are not seeing any liquid here. So we for in order to see it till 200 we need to resimulate it or you can restore the Phoenix simulation from current timeline also. So it's going to start from 93 and now it is going to go till 200 here. So if you press play, it is going to start from 0, but if you pause it and then play it, it is going to start from the frame that you have paused it. But if you stop it and now if you click on play, now you can see it starting from 0 again. So this is the difference between pause and stop. And Phoenix by default save every 3 or 4 frames depending on the grid settings that you are doing. But if I click on here, right now it's on 35. Now you can see it's not starting here because this is my restore point. But if I'm doing something like this, okay, and if I pause and if I restore, you can see it started from 62 there. Okay, so 63, 64, 65, 66 and 67. So it's saving every 5 frame here. Okay, that's a good thing here. And now you can see we are emitting liquid from our sphere here. Now, let's say you want to see your mesh here instead of this particles, this blue dots that you are seeing. Okay, these are particles, but let's say you want to see your mesh, how you can see that. So for that mesh settings, then your liquid settings, your time scale settings, you need to go to this grid here. As soon as you click on this, you will find lots of tab here, but we want to preview the mesh. So we are going to click on the preview here. So let's just click on this preview icon here. And now you can see we are seeing this particle preview. And here you can see it's written show mesh here. So if I click on this, now you can see we are getting this mesh here. And if I hide the particles, you can see our particles are now hidden. So if I zoom in here, okay, and if I hide this, now you can see we cannot see any particles here. Okay, and if I hide this mesh also, now we cannot see anything because now we have hidden our particle as well as our mesh preview here. Okay, and this is your preview, so it is not going to render it. Okay, for in order to render the mesh in high quality, you need to do certain settings also. We are going to look at that in another video. So let's just click on this show mesh here, and now you can see we are getting this result. Okay, now let's just go to some tabs here so you can quickly get up and running with Phoenix FD liquid simulation. So let's just go to simulation here. And if I go to somewhere around 83, you can see here we are getting all the details here. So if you see here, we are having the particle counts of total 4,872. Okay, we are not emitting any foam, splash or mist here. Okay, and you can see we are having a velocity of 321.32. We are going to change that also. And you can see we are having a grid of 90 by 94 by 52. So whenever you are resizing the grid, okay, for your scene, don't press R and resize this, or else as you can see, this will make it squash and stretch. Okay, so never do this. If you want to increase the grid, you need to go to your grid settings. Okay, which is our next tab here, which is our grid settings. Okay, so if I go here, you can see we are having this X, Y, and Z. Let's say your scene is bigger in X axis, then just change it from here. Okay, now you can see our grid is changing. So green was our simulated grid, which we did in last simulation, and this is our new grid. And now if I going to play, it will start till here also. Okay, so this is how you can increase the grid in X, Y, and Z axis. Here you can find there is a increase and decrease resolution also. So right now, if you see here, it's having a 4,872 particles. So let's just decrease the grid again to somewhat around here. Okay, and now let's just increase the resolution. So whenever you click on increase resolution, what will happen? Voxel size will get decreased. So let me show you what exactly and how exactly voxel works. So let's just have a box here. Okay, let's just click on this box. So if I am creating this box here right now, you can see this is what we call a voxel. Okay, so now you can see this is our voxel, current voxel. But if I increase the resolution here, which is this, now you can see our box is getting smaller here. If you see here, so let's just take our box this side. Now you can see our box size has gotten smaller. Okay, so we need to reduce the box size also. So first it was this, and now if I create a box, now you can see our size is around this. Now if I decrease it more, it will be decreased more here. So if I am going to increase the resolution more, it is going to get smaller and smaller. So whenever you increase the resolution, the voxels become smaller and you get the high quality simulation. So particle gets increased here. Let's just simulate it again. So you can see the difference. So let's just press this simulate button. And now you can see we are getting more particles here. Okay. It is not looking that good. Okay. So let me show you what exactly I am telling. So if I go here in my preview and if we enable the particles and disable the show mesh, you can see we are having this repetition here. So you can see the pattern easily. This is because our steps per frame is not that high here. So what is steps per frame? So let's say right now it's simulating from 0, 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. But now if I tell Phoenix FD that simulate like 3 frames from 0 to 1, so it would be going like 0, 0 0.30, 0 0.60, 0 0.90, something like that. If you say go 4 frames within 0 to 1, it would be like 0, 0 0.25, 0 0.5, 0 0.75, and then 1. So how you can increase that? So you need to go to dynamics here. Okay. And here you will find the steps per frame. So if I do 4 here and if I simulate it again, you can see we are not now getting that pattern here and we are getting this smooth flow of the particles here. Okay. Our liquid simulation. So this is how you can increase the steps per frame here. Okay. And if you are having a SSD or a good processor, your simulations are going to work really good, or else you need to wait some time before it gets simulated here. And now you can see here also we are emitting like 18,144 particles. If you remember, sometime before we were emitting only around 3,000 or 2,000 particles here. Okay. Now let's tackle one more thing. So before going into dynamic step, let me show you here in grid. Let's see now what is container walls. So right now you can see here, if you see closely, our emitter is emitting this liquid, but this liquid is not hitting the surface here. Okay. So if you see X here, Z here, and Y is forward and backward. So Z plus is upward, Z minus is downwards. Same way X this side is positive and this side is negative. And same goes for Y. Backward is negative and forward is positive. So here you can see we are having this container wall of X, Y, and Z here. So if I do here in Z minus, so now it is going to hit this surface here because I have jammed it in the minus here. So let me show you. If I click on play again, now you can see it's basically jamming the Z angle. So it's blocking that Z angle. And now you can see we are emitting the simulation, liquid simulation, and it's hitting our minus Z surface here. Okay. And after getting here to X and Y boundaries, it is getting killed. Okay. Why it is getting killed? Because if you see here, we have this both set to open. So if I do minus in both sides here and simulate it again, you will see on one side it is going to hit, and in on second side it is going to get killed here. So now you can see it's hitting here, but it is not hitting here, and it's hitting here, but it is not hitting here, because we have done this on minus side. So if you want it on both sides, you need to do jam both, and it will jam both the sides here. And now if I click on play, now it is going to hit all the 4 sides, 2 of X and 2 of Y and 1 of Z. Okay. So this is how you can jam the liquid in the container walls. Okay. So let's just stop it here. Now let's say you want to increase the resolution more. Again, as I told you, you can increase this resolution by clicking this increase resolution button, or else what you can do, you can decrease the voxel size. So if I click on this increase button, you can see it's decreasing the voxel size. So I can type it directly here also. So let's just go for 0.3, let's say. And now you can see we are emitting like 80 lakhs 86,128 particles. Okay. So total voxel size is that, not particles. So right now we are emitting 93,000 particles. So if I play it again, okay, it's now taking some time to simulate the scene because now we have increased the particles here. But you can see if I stop it here, okay, you can see now we are emitting like 2,79,708 particles. So you are increasing the particle size here. Okay. So this is the way you can increase the particle size with either increased resolution or decreasing the voxel size here. Okay. Now, if we go downwards here, you will find the dynamic step. We are going to take each and every steps in detail of this dynamics. in the next session. But before that, I wanted to show you the steps per frame, because sometimes what happens when beginner is working with Phoenix FD is confused that why my simulations are not looking real, because your liquid simulation is really fast. Okay, your velocity is really fast and hitting ground really fast. So if you see here, our liquid is hitting ground around 8 frames only. So this is 24 fps per second. Okay, so it's fps means 24 frame per second. So whenever 24 frames count, 1 second is created. So if it is hitting on 8, it's like less than half second. Okay, so this speed is really fast. So in order to maintain that speed and in order to get it look real, you need to increase the steps per frame. You can take it up to 12 also. Whenever I work with clients, I haven't gone more than 12, but it totally depends on the scene that you are working with. Okay, so if I'm creating a fountain, a waterfall, something like that, I go maximum up to 10 here. We are going to cover dynamics tab next, and our emitter tab also, which is having this velocity and all that stuff. And after basic videos, we are going to create some projects. We are going to look at some reference, and we are going to try to recreate it with the help of Phoenix FD liquid simulation. So hope you guys like this video. Share it with your friends who wants to learn Phoenix FD, and I will see you next time. Bye bye guys.